accelerating data value with network data. So I'm the country manager here at Zetaris, the network data platform for Canada. I'm going to be joined by our Chief Product and Community Officer, Jack Steele of Melbourne, Australia. So let's get into it, shall we? So when we talk about, it's not working. There we go. There we go. So we're going to break this into two parts for all of us. I'm going to do an introduction to what network data is, what we mean by that, and some of the nuances around the network platform. And then Jack's going to go into the real world example of network data in practice, specifically with data mesh, which I know has come up already in the conference. So very, very topical indeed. All right, so when we talk about network data, you're probably thinking, we already network our data, we connect it from one place to the other, we migrate it from this source to that source. What are you going on about? The main thing to keep in mind here is that we're talking about taking a different approach to integration. And the thing you want to think about is taking a virtualization first approach to your integration. And by that, we mean looking at data virtualization when it makes sense, where you can do it, which is getting away from physically moving data, physically copying and duplicating and so on. Now, when it makes sense to do that, you also do that. But for the most part, you want to think about using virtualization as your first port of call. So what's the problem right now in data and analytics? The big problem that we're seeing is that the Gartner says 85% of the products are failing, and that's due to this this methodology of always centralizing data, right? So before we can use it, we need to get that data, we need to pull it from its sources, and then we need to take it into various stages to clean it and transform it, and then we can use it for analytics, data science, and so on. Now, this leads to a host of problems, which we've captured here in this slide. There's the 3 V's, which are now the 6 V's of big data. The data quality can suffer as you move data through that pipeline along from source to the end user. Projects are taking too long and you're getting cost blowouts and so on. So this never-ending search for the bigger, better central platform for your data is a key issue and problem that we've set out to address for what we do at Zetaris. Why is this centralization a problem going forward? So right now, there's more data than ever before being produced. And as we move into the future, that trend is going to continue. With IoT and 5G coming along and the smart cities and everything connected, you can just imagine how much more data is being generated at every turn, at every day. And so if you're going to continue to keep trying to put your arms around that data and bring it in and centralize it, it's going to be a losing battle. And if you look at the description of this, we likened it to building an airplane while you're in the air. It's a never-ending game of chasing your tail to bring this data to a state that you can use it for your analytics, your use cases, whatever it is that you're going to do with it, right? So by doing that, you're playing a zero-sum game. Now, this slide here should be very familiar to a lot of folks in the crowd today. And this is just showing what we're talking about here. Traditionally, you're moving from left to right. You're taking the data in on the sources, and then you're putting it through these physical processes. You're copying it, you're duplicating it, storing it, backing it up, and so on, and trying to transform that into a very useful piece of data that you can then put out to your BI teams, your data science teams, into your applications, and create all those wonderful products and monetization opportunities for data. But as we've just run through, this is taking a lot of time and effort and leading to a lot of failed projects. So that brings us to this concept of data virtualization. It's not new, but the way that the technologies have advanced is something that is allowing new things to come through and allowing this networking of data through virtualization to happen. Another big advancement that we've had in the last few years is the increase in broadband connectivity, with fiber optics now becoming pretty much commonplace anywhere you are, with increased 5G especially. So the bandwidth is now there to carry much bigger workloads across networks and so on. And of course, with all the advancements in cloud computing and CPU and storage and things like that, you're able to do more and more and more computation on bigger data sets, right? So the technology is now caught up to a place where even 5 years ago it wasn't, and it's enabling this new ability to network this data, and in cases where you can, leave that data in place. Again, when we're talking about networking here and taking a virtualization first approach, it's leaving the data at source and not moving it before you get that benefit of analytics. So that's some of the new capabilities that have come through to enable this exciting new approach to data. What you get through the network data piece, and rather than the moving left to right, like we were on the last slide, is you get your consumers in the middle of the data. And your consumers in this case might be your consumers, your clients for your business, or internal data consumers, right? Your data scientists, your reporting people, and so on. And so it's really like bringing together the ability for everybody to collaborate on data in a lot more of a domain-specific way, to really allow your subject matter experts to get closer to that data and bring it together in more of a team sport, rather than having things, sit with IT, for example. So in this case, you're connecting to any data anywhere, whether it's in your data center, whether that's in a cloud, it's in an application, it doesn't matter. The idea here is that you're connecting it into this network data platform, and through the virtualization, getting that optimal mix of integration so that you can get to value a lot faster than the traditional method of taking it from left to right, as was in that other slide. Now that's all great and good. You're probably wondering about policy and governance, which is always a top of mind thing. Don't worry, this whole idea of a network platform comes with this thought, completely baked in. So within this this network platform and this virtual layer, you're able to really tune in a lot of fine-grained policy and governance practices. And because you're leaving data in place in most cases, that data is already behind the cybersecurity profiles and postures that you've set up. So if it's safe today, according to your team, then you're not really changing much by networking it, because again, you're not moving it. It's not leaving that location where it's currently deemed safe. So it's a real uplift to all the points that we have in here, data quality included. So that's what we mean by network data, networking data rather than centralizing it for your value. And so again, at this point, I'd like to bring Jack in to go through this real life example that we're seeing, which is data mesh, that everybody's crazy for. I mean, I haven't talked to one company yet that hasn't been at least thinking about it or looking into it very seriously. Jack?
Thanks, Ryan. That's a great intro. So so data mesh, networking data, the same thing really. So the whole point of the mesh is you're navigating across nodes on the mesh. And this section of the presentation, I'm just going to talk about how to build those and what's required and a good way to start. So just finalizing off this policy and governance piece, clearly, if you're not centralizing data, you still have to apply detailed policy and access control. You need to be able to make sure you've got standards. You've got to be able to make sure you're complying with regulatory requirements. So there's a lot of requirements around data. Data is one of the most sensitive places you can work. And by not moving the data, you're actually reducing the amount of compliance you have to worry about, because the less copies of the data you have, the fewer repositories it's stored in, it simplifies your whole access and control piece. So you can effectively, if you remotely connect in, all you've got to do is apply that access control to the query that's being pushed down, and then effectively you can mask, you can obfuscate, you can do all sorts of work on the result set as it comes back up. So you can very much control what your users need to see. So we've just talked about centralizing everything. It's far too hard. Now, this idea was the foundations of the data mesh, which Zhirmak Degani has done an amazing job of putting together. So really, there are lots of different reasons why the data mesh theory took off. One of them was basically the delivery today is too slow, it's too expensive. It's reliant on very, very specialized resources in the center. And those resources get overwhelmed with the amount of work that's coming in. The work just keeps on coming. Data's not stopping. In actual practice, most companies need far more data than they ever needed before, as customers demand deeper insights and they demand better experiences through digital platforms. The other bit around these driving factors is that the pipelines that connect these platforms together are incredibly brittle. They're not able to cope with changing data at the source. They generally just fall over as soon as there's a change. And the time to fix them is quite long, because you're ending up with multiple different systems having to be tested with dev, test, production, all those promotional aspects. So even if you've got good DevOps in place, it still takes a long time to fix these problems. And overall, what this means is you get disappointed stakeholders. They're spending an awful lot of money trying to get access to their data. They'll have invested in multiple programs over the years, and they still haven't quite cracked how to fix this problem. And as we said before, exponential growth. So we believe fundamentally that you should query the data where it sits and bring it into the center only when it makes sense. So we absolutely believe that data warehouses have a very valid use case. When you're trying to create time series analysis over a curated data set, and that's absolutely a necessary outcome for your business, then absolutely build a data warehouse. What we propose, though, is you network into that data warehouse, and then you can connect that to your cloud data lake, you can connect it to your operational systems, you connect it to your device data. So you're only moving data when it's absolutely necessary. So you're taking a virtualization first approach. And that allows you to scale as fast as your data is growing. So the data mesh, this is obviously the very interesting next phase that we believe will be the foundations of all projects going forward. So we've seen in the last few years that the cloud data storage and data lakes has been the primary method for large organizations and small organizations building out their data solutions. We believe that's going to evolve into the data mesh, where you still use data lakes, but you effectively augment them and attach them to each other by using the data mesh principles. And what it's all about is data mesh is about finding ways to push the data ownership back to the organizational units that control it, and for those organizational units to share those data sets that are useful across the organization. So lots and lots of different characteristics of that data and the data mesh to make that work. Clearly it's got to be highly performant and scalable. It's got to be self-service. As we said before, data quality and governance are key. And the real secret to all of this is it's got to be metadata driven. And in making it metadata driven, it can respond as fast as the data source is changing. So if you're scanning the metadata on the source and the table changes or the format of the column changes, whatever's changing, and you're scanning that, then effectively you can react really quickly. Most platforms today, although they claim to be metadata driven, they're not actually running end to end using metadata. So we believe that's absolutely key. So the metadata really forms a series of signposts for the query to hit the different repositories it needs to hit to. And then the idea being that you split the query into small bits and you use MPP processing engines, very, very large MPP processing engines to run those queries across all the different sources needed and then stitch them back together using in-memory processing wherever possible. So the cornerstone of data mesh is data products. They're effectively the nodes on the mesh. And you can look at them almost thinking like buildings in a city. So each data product has to be self-describing. It's more than just the data payload itself. It's also the policy, it's the governance information, it's the cataloging kind of information you normally get with most data tools. So it's the field definitions, it's the sample data. All that content needs to be wrapped up inside the data product to make it absolutely usable and discoverable. And the last bit about data products is they have to be interoperable. So you might have a data product which is sitting on your legacy data warehousing instance. You might want to be able to link that to your new data warehouse that you've been building over the last couple of years. You might want to link again through to an operational platform. So this idea that they're interoperable is really what's breaking most of the current thinking. You can't interoperate data unless you centralize. So we've built a solution which allows you to do that interoperation, which is without moving the data. And that's the key. That's the key, we believe, to moving fast and being able to get your business users getting the outcomes they need. So I've gone through these. So the data products have to be easy to find and connect is the last piece. So this idea that you've got lots of data products inside your organization already, but nobody knows they're there, this idea of dark data, that's another key facet to this. So if you've managed to curate your data products, even if you haven't fully integrated them yet, then at least your users, your business users, know they exist and they can ask it access and therefore investigate if they're useful for the particular problem they're trying to solve. And I know for a certain that data scientists and people who are trying to do exploratory analysis, the hardest problem they have is finding where the data is, knowing what it means, knowing if it's secure and trustworthy, and being able to get access to it. And that's where the data mesh comes into its own, because it reduces that friction, and therefore it massively reduces the time to value. So I'm just going to go through an example of an actual data product, because we talk about these things, but you've got to actually anchor it in reality to make it make sense. So this is an example of a sales data product. In this case, it's revenue. So it includes accruals and prepayments and all those financial adjustments that happen. Now, the idea of a data product is it's owned by a business unit. So it's got full, and we've talked about ownership for a long time in data. So we've had data owners and data stewards, but data mesh really moves that idea and makes it real. So it's saying, okay, this product is owned by the head of financial reporting, and they're accountable for making sure that that product is being used as it's meant to be used. They write the policies over the top of the data product. And we use this idea of federated governance to make sure that access control and everything else is properly applied. So in this case, this sales product might be part of a report, or it might be part of maybe some kind of data science model, maybe a customer lifetime value model, where you're trying to understand the sales that have been made to that particular customer over time. Now, you can get another sales product, which is owned by the head of accounts receivable, which is your billing data product. Now, data products have to make sense to the organization that's built them. So this isn't the idea of centralized data modeling where you try and conform everything to one definition. It's absolutely fine for these data products to have localized context. And then it's the job of the information around the data product to explain what it is and how to use it. So that if you know it's a billing data product in this case, you know it's absolutely suitable for integrating into your web application to show customers on their invoice history, for instance. So there are other data products which are aggregated data products, and other ones which are sort of joined and conformed and standardized data products which are fit for purpose for external consumption. So what we're talking about here is more raw data products, which are kind of source system or source process aligned, but obviously those other products exist as well. And when you take this to the extreme, you get towards things like single customer views, which we don't recommend really trying to build to that level of complexity. You would be much better off having multiple data products that you join together when you need them to build the customer view that you're looking for. And then the last sales data product here might be your contracts view. So 3 products all called the same thing, all owned by different areas of the business, but very, very clearly articulated when you're navigating to find them, exactly what they should be used for, the access policy, the data sets that are contained within them, and all that sort of information. All that stuff wrapped up together is a data product. And what we've got here is 3 things called the same thing. That's Zermatt has defined these as polysemes, which is a great construct that I hadn't known about before I investigated this in real depth. Polysemes just means same name, but different local meaning. And these things happen all the time across businesses. And it's generally these areas which cause the most friction when you try and do centralized governance and centralized ownership. So which ones to build first? I've got 2 images on the slide here. So the left-hand side is the gas station. I'd always recommend building these types of data products first. So they're simple to build. You've got lots and lots of consumers for them, and they're going to be frequently accessing them. And it's really easy to understand. So that's where you start with your data mesh journey. The Guggenheim on the right-hand side, that's a bit like your single customer view. It's going to take you years to complete. You're going to end up with probably multiple project failures along the way before you ever get there. So start with the simple, easy to build, not necessarily the highest possible value to your organization, but the product which gets you off and running and gets data mesh, product's idea, really embedded inside the organization with some good stakeholder support. Now, we've already talked about data governance a couple of times. Data management also still massively applies to data mesh. So don't think of virtualization or the data mesh as being something that bypasses data management. It's absolutely still required. The same questions we have on the screen here, is it complete? Where does it come from? What does it mean? All these questions will apply in the data mesh, if not more so, because all of a sudden you've removed the friction from being able to find where the data sits. So that's the key part of the data mesh, and the solutions that we build incorporate all this, because we know that providing data or frictionless access to data needs to come with all this extra management and governance. Otherwise, you end up with all sorts of compliance problems you didn't expect. So although you solve the problem of not moving the data, you still have to apply the standard data management aspects. And in terms of getting started, we absolutely recommend building on top of what you've got. This is not a rip and replace approach, the data mesh. We believe that the data mesh should be all about exposing the data products you already have inside your organization. So on the left-hand side, this technology stuff, you might have a really nice data mart sitting inside your warehouse, which has your general ledger in there. And that's fine. You can expose that as a data product. You might have a data lake where you've got some nice data sets in raw format that you want to expose, and they're very large. You don't want to move them around. So absolutely, you can create effectively a product card for those and expose that, and then enable linking between that and the data warehouse data products, all the time running these queries remotely. So absolutely, leave your technology as it is, the core technologies. Use this to accelerate your journey, but don't sort of abandon your principles. If you've got a principle which says, I still want to go to centralization for these core data sets because I've got some very good reasons for it, absolutely continue with that journey. What this data mesh approach allows you to do, though, is avoid having to centralize where you really don't want to. And the only reason you're centralizing is to allow the query to run, because that's the worst reason to centralize data sets. So on the right-hand side, we've got the organizational aspects of data mesh. Now, it is absolutely both. So data mesh is not a technology approach. It's a kind of combination of organizational change and technology. So the learnings everyone's had from their agile journeys, and most companies have had to go with agile to different extents. Agile is very similar to data mesh. It's a team sport. So it's all about bringing your different teams together to work on a business problem, or in this case, a data product, which then you're going to share widely across the organization. So the agile disciplines work really well for that. DevOps is clearly still needed because you've got to be able to crank the handle on these things quickly. You've got to get these products out to market fast. And also your existing structures where you've got data owners and data stewards can very easily be reused in the data mesh world, as well as your data governance forums and everything else. The trick with data mesh, though, is this idea of federated data governance says you apply the data governance back to where the data is being run and owned, to that where the product sits. And you do it in a federated way. So you're trying to avoid centralizing everything through the middle, which is what we used to do, which creates bottlenecks. So any kind of centralization will create bottlenecks around resource availability and time, because you end up queuing. So the idea of data mesh is because you're federating as much as possible, you're reducing that impact, but you're applying just enough governance to make sure that all of your key foundational processes are safe and secure. So it's certainly not no governance. It's just the right type of governance to sort out the problems you have as an organization. And then getting to the starting line, and then I'll close the presentation. So just recapping where we've been, and I think we've got a few minutes for Q&A, which would be absolutely fantastic. So getting to the start line, the first thing is pick that data product, which is going to really make an impact with your business. So find a business owner with a problem, and then solve that quickly by not giving them the most complex data product possible, but the thing that's going to get them off and running. Now, this will be different depending on the line of business. So, a telco, it might be their location data stats that they want to be able to share because it's widely used across the organization, and you'll get a lot of people, a lot of value. Or it might be for a retailer, it might be shopping cart information. So pick the product that works for your organization. Keep it as simple as you can so it has value in itself, but you're not having to jump through too many compliance hoops or too many issues with the ability to share the data. Make sure that the product you're building is kind of aligned with your current maturity for being able to consume it. Work as a team, because any of the groups you miss out on this journey will be the ones that come back and bite you, basically. So technology obviously have to be part of the approach. Your support teams, your governance teams, and the business team. So getting everyone together, and that's why the agile approach is so good, because lots of companies who've been on that journey have already gone through that journey of bringing everyone together and kind of dropping the organizational silos and simply saying, right, what's the problem we're trying to solve? Let's bring a cross-functional team together to solve it. And I think the last thing is that centralization if your journey to date with centralization has caused you pain, if it's been too slow, if you're not able to keep up with the demand, then that's the storyline to tell, to say, well, if we keep doing this, we're not going to get to the point of real business value. We have to do something different to make this work. And that's what this presentation today is all about. It's saying, network your data, don't just centralize it. Centralize where it's absolutely mandatory, but bring in the networking approach to really speed up the value you get from your data. So thank you very much. That's the end of the presentation. Very happy to take questions.
Can you hear me?
Absolutely.
Yep.
Perfect. Sounds good. As far as things go, how would you differentiate from a data virtualization tool such as Denodo?
I think that there's a lot of classical approaches out there to virtualization, which are, you're just virtualizing the entire data set that you're trying to look at. What we do is we're all about cross-querying across multiple data sets at the same time, really, really fast. So we're all about, you're connecting to multiple platforms at the same time and spinning out queries that cross-reference all of those, and then having all of that analytical governance over the top. So, this sort of operational virtualization, which we used to have, that's not the style that we're doing. We're doing analytical data virtualization, which is to support the questions your business has and your data science type activities. That's really where we play, where our strong suite is.
Yeah, I was very pleased to hear that data starts to get to sit in the original source location and not have to be shoved around to intermediate repositories. You used the word data steward earlier on, and I'm familiar with a couple of years ago with data owners. Yeah. Are there subtleties in the word data steward we should be aware of and watch for?
Yeah, I was data stewards were, and it's all part of the different styles of data governance. So data stewards typically sat inside business units, and they would be responsible for different objects. So your data steward might look after the quality of maybe your product list. So they're the ones in there making sure the DQ rules are properly written and making sure that, the MDM tool you've got to kind of bring all those components together and standardize them is working. And what I was saying in the presentation is, if you've already got data stewards, they're fantastic to help you with your data mesh journey, because they're already interested in the data sets which relate to those data products, and they can help make sure that the data products you're building are interoperable. And that's where this comes in. So MDM as a topic is related to data mesh, but it's kind of a higher order thing. So once you've built your data products, your data master data management, your traditional data modeling approaches, they help you understand how to join stuff together. So when you're creating aggregated data products, those sort of disciplines come into play. So hopefully that helps explain. So the steward has been a level of accountability and responsibility, but the problem was they didn't own the core platform that ran this stuff. So you always had a problem, which was kind of, I'm the steward, I'm accountable for data quality, but I don't have the ability to fix the data, and I don't own the platform it's running on. So, and that was, if you move the whole ownership back to the source team, and you effectively say, look, the data product now sits in your space, and we federate out how it's built. So we're not trying to build every data product using the same platform. That's why you could have some on Teradata, you could have some on SQL Server, you could have some sitting in the data lake. It means that each of those teams can make sure they've got the right technical staff to pivot and twist when they want to move those data products and change their definitions. So avoiding that central team with the bottleneck of saying, right, you've got all these data products across the organization, now you're funneling through one central team. We've seen it happening. It just doesn't work once you start scaling. It will work for maybe the first 6 months when you've got 20 engineers, but then you've got 60 engineers worth of work coming through the pipe. So that's when the whole thing slows down and stops working. That's why federation is in ownership and delivery is the next stage after you've kind of started your journey on the data mesh.
Teresa mentioned that she knows about centralization tools from her last experiences. What tools do you use to network instead of centralize?
So that's the platform we've been building for the last 8 years and testing with clients. So whilst we're not trying to do obviously a vendor pitch here, we've obviously built this technology out. And if you're interested in knowing more, then definitely reach out to us after the presentation. We'd be delighted to take you through some demonstrations of what we've done. But basically, the market doesn't have these tools at the moment. There are tools which allow you to do sort of SQL on a data lake. There are tools which do classical data virtualization. But what we've built is what we believe is necessary for the data mesh, which is, and actually what happened was the data mesh methodology kind of developed in parallel to this thinking was, centralization isn't working. We need to build something which will run analytics in a distributed way across a network. So we came up with this hypothesis 8 years ago. Data mesh has probably been on a very similar track. And now the great thing is that we've come to market with a product which actually fully aligns with the mesh methodology. We're absolutely not trying to centralize. And also you'll see some vendors try and whitewash this approach, and they say, bring your data into our cloud and run a data mesh in our cloud. Well, that by itself means you're not doing data mesh because you've already centralized everything and had a central team having to own and maintain that.
Well, we're going to get close to wrapping up, and to give people another 30 seconds or so to type in their last question, I do have a final question, because you mentioned agile and data in the same sentence, and I'm a big fan of agile, but I've often had difficulties talking with data modelers to go, how do you model just enough? Why did you speak so glowingly of agile in that one little mention you gave?
So for me, agile is a mindset. So it's saying, bring cross-functional teams together to work on products which will delight your customers. That's the purpose of agile. So you're breaking out the organizational boundaries you used to have and saying, actually, doesn't matter where you report into, come together into a squad or a scrum team, whatever you want to call it, work together on the business problem and work really fast and deliver something that has real value. That thinking is very, very similar to the data mesh thinking, which is build data products so that they're owned by a product owner or a business owner, get them done quickly so that they are out in the market and usable and valuable. So don't try and build the enterprise data model. Don't go through that approach. Build MVPs, build small components, and then network them together. So what data mesh is doing is taking the best of an awful lot of different approaches which have been proven in the market. APIs also. So APIs are another way of doing a similar thing, where you're thinking, how do I build consumable components which I can network together? Data mesh is taking the best of that as well. So that's the main thinking.
Sounds good. I have a couple more questions. One is talking about the data mesh from David. And he said, is using a data mesh generally lighter on processing and server storage, and therefore better for the environment, lower power and emissions?
Yes, I think that's actually a fantastic byproduct of not moving the data and copying it again. Now, clearly, what we've done to avoid re-querying the same data set again is obviously a lot of caching technology. So to make this work and to lower the impact on the environment, you've got a cache result set. So we've got a lot of that built deeply into the platform. There's actually an odd side effect of being able to run querying remotely as well, though, is if you can actually run your processing in a data center which sits right next door to your green's energy supplies. So there's nothing stopping you running your data center in Iceland and querying the data in a completely different jurisdiction. And that's quite unique because you're not needing to move the data to the processing area. So we've proven that we can run Sataris across cloud compute, across the US, across Southeast Asia, across Australia. We've got demos running, showing that running, where you're effectively pushing out the queries and bring them back in. So yeah, there's a side effect, which is that as well. So the main thing is you're reducing the amount of storage and movement of data, which is obviously reducing total compute. But then you can also relocate your compute to the place where you want it to run.
Okay. Lee has a question about talking about the stress of analytical workloads on transactions and source systems in a networked approach.
Absolutely. That's absolutely key. So, traditional approaches to virtualization had a really bad reputation because they would create an awful lot of load on the source platform. So with modern approaches using MPP platforms, you can effectively cut down the amount you're querying and really partition it to very small compute bursts so that you're stitching them all back together again. So this idea of sharding everything down into very small components, that helps a lot for operational platforms because the compute they have to run is much shorter. But we recognize that even with that, you still need to reduce the numbers of times you hit the platform. So that's where the caching comes in. And then thirdly, you might decide even with that, you still don't want to query during peak times. And that's where you can schedule effectively your virtualization to run and warm up your caches. So it really does depend on the platform you're working with, the approach you would need to take. And we absolutely recognize some platforms, you really don't want a virtualized tool running on it directly. So you might work off an operational mirror, or you might work off an existing extract you've already taken. And so, you can minimize the amount you touch that operational platform by taking all those different approaches. And, I'd recommend that, as you would with any of your analytics requirements, if you need to analyze the data from that platform, you've probably already thought through some approaches to how to minimize the load. All we're doing is giving another option, which is don't move the data at all. So you might decide you still stick with the nightly extract because you don't want to risk it. That's absolutely fine. For those platforms, not a problem at all. But there might be other examples where you've got maybe massive log tables and it's too hard to move the data and you want to cross-analyze all your log tables for whatever reason. Maybe you're trying to pick up some kind of cyber issues or something else. In those cases, it's an absolute no-brainer to run the analytics on those data sets because then that platform itself is not going to be impacted at all by the load.